Hello and welcome to the GigaSpaces Cloudify for Azure. The GigaSpaces Cloudify for Azure enables Java users to deploy the application on the Azure platform with no code change. It was designed to support not just basic Java application but also enterprise-grade application, as we'll see throughout the demonstration. The demonstration itself will be based on the Spring Travel application, which represents a classic enterprise application stack that includes a load balancer. In our specific case, that's going to be Azure, a web container, in our specific case that will be Tomcat, and a database which could be either SQL Azure or NoSQL. For the sake of interest, we've chosen a NoSQL database. Through the demonstration, we'll show how we can automatically deploy that full stack in a single command and manage and monitor the application using the Cloudify management console. Before we begin, we need to do an initial setup. The initial setup applies once to all our application, and usually that includes the registration for the Azure, downloading GigaSpaces, and using the GigaSpaces, the Cloudify environment to set up our initial environment within Azure. For the sake of time, we're not going to spend too much time on that procedure. After the initial setup, we'll end up with a Cloudify environment on top of Azure. The front end of that environment would be a controller, which is basically a REST service through which we're going to browse through the console and see the services, or interact through an interactive shell that we'll see later on. The Azure adapter is used to interact on our behalf with the system and scale in or scale out instances as needed. The result of the deployment will include a worker role instance, which is basically an Azure machine. Within each machine, we'll have an agent. A Cloudify agent will be responsible for instantiating the actual services and reporting back the state and the statistics of those services. And obviously the services themselves, in our case, that would be a Tomcat service for the web container and a Cassandra service for the database itself. After our initial setup, we can log in into our Azure environment on windowsazure.com, browse to the hosted services to get our management console, and basically get the IP. Now that we got the IP, we can log into the Cloudify management console, log in into that management console and browse for the information, which will basically include the total memory, the total CPU utilization, the services that are currently running. In this specific case, that would be the management service. And we can see some of the statistics of that management services. Now that we've got our Cloudify environment up and running, we're ready to ship the travel application. That includes two steps. The first step would be to prepare the application. This is where we package the WAR file, the Tomcat web containers, and the Cassandra database, and use a recipe to tell Cloudify how to install those services, in what order, and how to manage that. We'll learn more about the recipe in later slides. Now that we're ready to deploy the application, all we need to do is just click on a single command on the Cloudify command shell. That will tell Cloudify to package the application and ship it into the Azure cloud environment, by which the Cloudify service will unpackage that, read the recipe, and provision the instances on the relevant machines. The result will look something like that. We'll have instances of Azure worker role up and running. In each instance, we'll have the GigaSpaces agent, Cloudify agent, with the Tomcat service up and running. The load balancer, the Azure load balancer, will be the front end and provide a single endpoint for that entire environment. Now let's drill down into the actual recipe itself. The recipe tells Cloudify how to package the application, how to provision the services, and in what order. It is built as a DSL, a domain-specific language, which is based on Groovy. It includes lifecycle script like start and stop, the same script that we will use to run those services if we would do that manually. It includes more advanced things like custom plugins to tell Cloudify how to manage the application, how to monitor it, and how to visualize the statistics of that service. It includes binaries that could be provided either by a reference or the binaries themselves could be included within the package itself. The same applies to the application boundaries. These steps is usually done once per application because usually during the development cycle we don't really need to change the recipe itself. To save even that step, the Cloudify environment comes with three built-in recipes. The first one would be the Enterprise Spring application, which is the one that we're using for this demonstration, an in-memory data grid for caching, and the big data recipe for provisioning databases, NoSQL databases like Cassandra. Now let's see a snippet of how that recipe would look like for our Tomcat service. As you can see, it's pretty self-explanatory. We've got the service name, got lifecycle events, which, as you can see here, the install and start script are provided in Groovy, and the stop service is actually a batch file. So we can mix and match between those scripts. It also includes the monitoring plugin that tells Cloudify which statistics and metrics we want to monitor from that specific service. And we can also point to the user interface plugin, which tells Cloudify how to visualize those metrics within the Cloudify management console. Now we're ready to get started. The first thing that we're going to do is deploy the Cassandra database. We can see the Cassandra recipe, and we can watch the definition within the recipe itself. It's very similar to what we've seen in the previous slides. It includes the start and stop command, install command, the metrics that we want to manage, and some specific things that Cassandra really needs. To deploy the Cassandra service from that folder using that recipe, we need to open the Cloudify command shell. The interactive command shells enable us to install services and deploy and manage those services. Before we can do that to the Cassandra service, we first need to connect to that service. We'll use the connect command from the Cloudify command shell using the URL that we've used for the management console. And that will basically get us plugged into the system. The second thing that we're going to do is create a context for our application. The context is important so that next time when we're going to deploy the Tomcat service, both the Cassandra and the Tomcat will be displayed under the same context within the management console. Now we're going to install the service of Cassandra, and you can see that the command itself is pretty self-explanatory. We use the install service and point to the name of the folder that includes the actual recipe itself. Behind the scenes, what happened is that we package that folder, send it as a zip file, and now we can see in the command shell that the context itself of the travel application has been created. And if we'll watch closely, we could see that the Cassandra service is currently in the process of being deployed. If you watch carefully, you could see the progress icon on the right-hand side. We can also see the service view, which is basically a network view. And if we wait a little bit, we can see that the Cassandra service is now being marked with V, and it's actually being deployed. We'll do the same thing for the Tomcat service. We're going to do that quickly right now, and I'm not going to wait too much time with that. And we can see the same way that the Tomcat service has been added to the travel context within the management console itself. One thing that is pretty unique here is that we can also see the custom metrics of that service. And we can also see the overall dashboard of all of the utilization of all the application and how they're being spread. Now we're going to log into the actual travel application now that everything is being deployed, both the database and the Tomcat service. We should be able to interact with the travel application and browse through the data. Obviously, when we browse through the data, that means that the database itself is also up and running. And it also includes all the information, the state information that we expected. So what happened is that we actually deployed a full stack application into Azure with the database, with data, and all that in one click. So it's all being automated. And that's kind of the purpose of the entire thing. Now we've seen how using Cloudify, we can take a full stack Java application and deploy it on the Microsoft Azure using Cloudify. The next thing that we need to worry about is what happens after the deployment. That usually includes the failover and failover event and scaling event. We'll start with the failover event. Usually when something breaks, the system itself within Cloudify has an agent in each node, so it can detect when the failure happens. In that case, it will report that failure to the management console, but also automatically provision a new instance to take over that failed instance. In that case, the system will continue to work as if nothing happened. The other thing that could happen, and that will be handled in pretty much the same way as in failure event, is that we're running out of resources not because of a failed machine, but because we have more concurrent users in our systems and we're hitting more traffic than we started with. In that case, the Cloudify will detect that situation and add another new instance into the system itself. So now we can see that instead of 3 Tomcat services, we have 4 Tomcat services sharing the load, and the load balancer itself will take responsibility for sharing the load within that instance. Scaling works. Usually auto scaling involves 2 steps. One is to add instance, and the other one is to let Cloudify provision the Tomcat services into that instance. We can see that we moved from 2 instances of Tomcat to 3 instances of Tomcat, and soon we'll see that Cloudify provisioned the Tomcat instance into that new machine. And now we can see that we have 3 instances of Tomcat already running. Now that brings me to the end of the demonstration. We could also see how we can take a typical enterprise Java application with a full stack, deploying on Azure seamlessly. We could also see how we can easily manage and monitor the application using the Cloudify management tools. Another aspect which is quite interesting is the fact that you could run the exact same thing that we've seen on Azure on your own local environment, or any environment for that sake. In terms of availability, the actual full version of that product is going to be available for beta during the July timeframe, as you could see here. We're expecting a full general availability around Q4 of this year. If you're interested for more information and updates, please log into gigaspaces.com/Azure, where you could find all the updates on the latest release. You could register for the beta and get updates through emails. And you could also look at the full webinar of that session and see the full details. Thank you very much for listening.